and welcome to PCB Chat, where we talk with experts across the printed circuit design, manufacturing, and electronic supply chain fields. I'm Mike Buteau, president of the PCEA. It's hard to believe, but in the 8 years I've been podcasting, I have never had today's guest on. A warm welcome to my good friend, Steph Chavez. Steph is Principal Technical and Product Marketing Manager for Siemens, but he's best known for his 3 decades as a printed circuit designer and instructor. He's a regular contributor to various industry publications and host of the Printed Circuit podcast. See, everyone has their pod. He also co-authored and teaches the PCEA training certified printed circuit designer curriculum. One other thing, Steph is chairman of PCEA, which makes him my boss. But that's not why he's on. Hi, Steph, and welcome at long last to PCB Chat.
Morning, Mike. Thank you for having me on. Finally, I was wondering why it was taking so long to have me on the show, but no, it's fitting. It's all good, and it's an honor to be here, and I'm eager and excited to engage with you on some good, fruitful conversation. What's happening in the industry today?
Well, I'd say it's a case of saving the best for last, Steph, but this is hardly going to be my last podcast. So today we're going to talk about some of the issues designers are running into. And also, you have a couple of presentations coming up at PCB West, so we'll touch on those. And we will wrestle with the world of academia and what's happening at the college level, where you've been teaching of late. Let's start with the industry, and then we'll work our way into the academic setting. I'm going to jump right in. You talk every day to designers. If you could summarize, what are the top 2 or 3 problems they seem to be encountering right now?
That's a great question because, there's a diversity in the different spectrums of design, whether you're designing digital designs, high-speed digital or RF or analog, or maybe you're just designing, something, I want to say simple, but less complex is a better word for simple. It's just less complex. But the fact is that, in general, the typical top 2 or 3 responses that you'll hear or that I'll hear is that designers, have to deal with vague requirements or scope creep. I mean, especially if you're a consultant, getting the requirements right or getting all the requirements in under the agreed upon timeline that you're supposed to deliver your final outputs is an issue. Designers frequently start projects, with unclear and incomplete briefs from their clients or their stakeholders, with ambiguity can lead to multiple revisions or wasted effort. And, time is money. And, there's a lot of, as projects progress and things move forward, you have a lot of changes that hit, and you've got to learn to deal with changes and utilizing your tool sets to deal with that. It helps, but the fact is, scope creep and vagueness is an issue. The second thing I would address or mention is like conflicting feedback. You get feedback from your stakeholders, and maybe you might not be in alignment, or maybe you have multiple stakeholders and even they are not in agreement. So therefore it causes ambiguity, it causes delays, it causes unnecessary respins potentially. There's just a lot of issues in general when it comes to conflicting feedback during the process of design. And the last thing, or the third thing I'll mention, that's a top one, is the technical limitations and implementation gaps. When you think about common frustrations for designers in creating what we would say is a beautiful functional design, but it cannot be fully or efficiently implemented due to technical constraints. Such as platform limitations or budget or development development issues, or even the developer or the designer's skill set. There's a lot of things that can come into play that can cause gaps, or if there are gaps in any of those situations that could cause issues. So I think those are the big 3 that I would say in general, whether you're, early in your design career or even a seasoned veteran like myself. These are the top 3 that I'd say that would plague designers the most.
So when you talk of scope creep, Can you give me a little bit more color about exactly what you mean? Is that just added requirements?
Yeah, so I would tell you, one of the simplest things when I think of scope creep is, let's say you're started or you agreed upon that you're going to do a certain set of schematics that you're going to start with to do your layout, and all of a sudden, a few more sheets get added. Or another way to look at it is if you started off with your project meeting with the team with all the appropriate stakeholders, and it was agreed upon that there were not going to be any test points required. But yet, when you're finished with your design, they come back and say, "Well, we've decided we want you to add test points to every net, every required net, a signal net." Now that could be a day or two, or it could be 2 weeks to go back and add those in, but you didn't account for it on the schedule. So there's little things like that where you get changes that they'll say, "Well, it's only a few more connections, or it's only a few more parts. Just squeeze it in." And those weren't there in the beginning, or that they weren't anticipated, and therefore you end up over budget and over schedule, and that happens. Or I also see where like budget creep happens is where when you have a design cycle and when the double is starting to piecemeal data to the designer doing layout, and as he's feeding some circuitry into it, the designer started earlier than anticipated per the schedule and layout, but the electrical engineer will think, well, I'm getting a jump on it, and we're getting to layout sooner. So you're checking the box. Yeah, I'm in layout, but he is continually massaging the schematic and massaging the schematic. And by the time you realize it, the estimated allocated hours for doing layout is actually expanded beyond what was allocated, because you brought them in sooner thinking, well, I'm going to finish sooner. But in reality, you didn't. You kept making changes and you kept making changes. And therefore, the designer is just doing as best he can to try to address the changes coming at him or her. And he or she is billing hours or billing the project. And then you have creep. And that happens. It happens all the time. From the beginning of my career, even now, after 3 decades, scope creep is an issue.
Even after the kickoff meeting and the design rules are hard coded and all that, people are still encountering all of these engineering changes add on.
Correct. Yeah. And part of the problem is, we really felt it after COVID. I mean, we hear the phrase, now you hear it regularly, is supply chain resilience. And one of the things that, I'll touch on this is that, with the tariffs and, part issues or part delays and that are happening, the problem is what do you do when you're the double E and you finally designed your circuit and you're already into layout, and the designer did an amazing, you two as a team did an amazing job, and all of a sudden at one of your project meetings, your supply chain team member says, you know what, I'm sorry, those 30% of your bill of materials is not available. And, part of those 30% of your bill of material are key critical circuits, are components that you needed for your circuit in order to deliver a certain requirement that the customer, was asking for. So what do? Do you, continue forward and you just have delays in delivery and you miss your deadline to deliver the final product? Or do you ask your customer what requirements can he live without? Or do you go back and reinvent or re-engineer with the circuit using alternative circuitry to be able to do the same equivalent requirement or the same equivalent circuit, which may require additional parts that are beyond, let's say it only took you, like, let's say, 20 or 30 components to do what you did, or maybe, 2 or 3 key chips. Well, now there's no really equivalent chip, one chip or one IC to do that part. Now you need 3 ICs and all of its respective circuitry. And that is just a ripple effect, and you're having to take 2 steps backwards. And I experienced it significantly in a negative way with taking not just 2 steps back, but like 2 leaps back. When COVID first hit, and I was working at one of the Mill Aero companies one of the leading mill aero companies, and that became the norm. And it was brutal because there were times where I think I counted or I tracked, I must have changed that design 12 times in order before we finally got it to market. It was brutal, and it was driving us crazy. Not just me, but the engineering team.
You had mentioned the beautiful functional design that all designers are after, right? And I know that routing is a really big part of this. Designers hand route in part so that they can keep track of everything in a way that it's maybe a little bit harder to do with the auto router, but also because the aesthetics of it, are really pitch perfect, right? Every designer has their own style and flavor and touch. Um, so let's talk about that a little bit because you've been a big proponent over the years of using the auto router as part of the CAD tool to its fullest extent. And a lot of your colleagues, as instructors, feel like, hey, look, hand route it, don't trust the auto router, and they really say the opposite. So, how do you come by your thought process here?
That's a great question and a great topic. When you think about, automation today and where we've evolved, as designers of our craft as well as the EDA tools today. Um, and let's face it, electrons don't care what they look like. When you think about the true, basics of signals, but what they care about is they care about, who's affecting them and how, if they're affecting someone else. So that's just, and it's like a very basic raw, form for people who really don't understand electronics. But the fact is that when you do a layout, it will look beautiful regardless. But the key here is workmanship. And it comes along with experience. And do you know how to design a board correctly? That's the key is, do you know how to design it correctly? Whether you do it manually or now today, when we say manual, it's more like interactive because you're not manually doing it like, 2 decades ago or 3 decades ago when it was truly, there was no, constraint driven designs, whereas today it's all constraint driven for the most part. But, you know, automation, you have to embrace it. And today's tools have the capabilities are far superior than, 2 decades ago of those tools back then. And back then, it was horrible if you tried auto routing. It was a nightmare. And I was totally against it. And I never thought I would auto route. But, there was a point in my career, and I talk about it at several different, presentations or different industry conferences and shows where I share my experience of when I took the leap and tried it and the impact it made, not just on me, but the electrical engineering that I was working with and the ability to finish faster and adapt to changes as they hit me. But the first thing I'm going to say is not every design can be auto routed. Along with getting experience and becoming a seasoned designer is have to understand when the opportunities exist and when to utilize automation to your advantage. Now, the bottom line is if I can get, 18 hours of effort in an 8-hour day, wouldn't it be worth my advantage to do so? Rather than, like I used to do is, I always felt I was never the smartest person in the room, but, you sure as heck weren't going to outwork me. I was definitely going to be the one who was going to say, I'm going to dominate you with, I'm going to work around the clock and do whatever it takes to get it done because I think grit is a big thing designers have to have and one of the many traits and being able to persevere and push through and get the job done at all costs, whatever it takes. And but today, when you embrace the automation of the tools and use them to your advantage, but you have to pick and choose when the opportune time to do that or use those functionalities and use it to your advantage. And I would ask any EE if I could shave, a couple of days off on the layout to get you in the lab faster, to give you more time in the lab with that hardware. I have no doubt, 9 times out of 10, those EEs would be like, heck yeah, I would like it. I would like more time in the lab with the hardware. And I would ask anybody if I could give you 1 hour back in your day to do whatever you want, personally, to do whatever you want, would you want that 1 hour? But what if over a week I can give you 8 hours? figure an hour a day, that's 8 hours, or five hours. That's a half a day's of work. If I could give you a half a day off every week, would you want it? Yes. Well, think about automation and how much time it can save. Some people say, well, it's not really saving me. It's only saving me 20 minutes or 10 minutes or 5 minutes. Well, if you add those nickel and dimes up, you could start, cultivating that and to be a better version of you as a designer. And another thing I look at is, the tools and the evolution of the tools are getting more and more expensive versus, 2 decades ago. So you're paying or you've paid for a tool that is expensive and you're not using, all of the automation, or you're only using the same 20 clicks that you've done for the last 20 years, why would you do that? You're leaving money on the table. I think we all have the opportunity to be a better version of us individually as a designer. And I think those of us who continue to cultivate that skill set and master our craft, which means that entails mastering the tools as well, it's in our best interest. And, the newer generation that comes out of college, they're already ingrained in the digital age. So they're more adaptive to using the tools to the advantage versus a legacy engineer such as myself, who didn't come up using this, in the digital realm, so to speak. And so, automation is there. And I think those of us who take advantage of it, uh, it will make a difference, and it is a game changer. And those that don't, and don't get me wrong, they will still achieve success. It will just take them a little longer to do it. And, some people will say, well, mine, you can tell it looks better. You know what? Put it on the scope. Don't aesthetically look at it for appeasing to the eye. What does it look like on the scope? Are the DBs the same? Is it, what does the signal integrity or the signatures look like? And, I guarantee you it's acceptable and it can do the job. Most of these complex designs, very complex, that you see some of these competition winners, if you're not utilizing automation to help in some form or factor, you're not going to get that job done in the period of time that you need to get done, especially when you think about how quick can you adapt to changes. For example, if I routed some DDR5 memory and I got all the fine tuning in, and let's say I got a 2000 pin VGA and I got all this routing in, all of a sudden I got to move something, or I got to I have to put a mounting hole somewhere, or just whatever. I got to move something that's going to require a setback. The question is how quick can you recover from that and continue to move forward? If you utilize automation to help reroute or rewire those connections and retune those connections, using automation, you could do that faster and recover faster. If you're doing that manually, it can take, several hours to several days to maybe a week or so to do so. So utilizing automation to your advantage is key. And you think about the evolution of designers in general, or engineers in general. One of the things I will tell you after, 35 years in the industry of doing this is work-life balance is real. And I say real is that when you're young, you don't think about it and you're just bullheaded and you'll work around the clock. Believe me, I've done many years of working 18-hour days. After all this time, now that I'm where I'm at in my career, I will tell you today's tools, you can get a high level of effort in less amount of time if you embrace it and use it to your advantage. But everyone has a choice and they will do whatever they do to achieve whatever level of success that they're okay with. And for me, personally, I will embrace the automation and use it where I can. And like I said, you can't utilize the auto router on every design. Think about high power or RF design, but there are steps within the process that maybe you can use some automation here and there to help you. That can shave off a little bit of time here, a little bit of time there. So my advice is to embrace it and utilize it, because I guarantee you your competitor will, or the individual you're interviewing against to get that job is going to be using it. And who do you think your employer is going to want? And like I said, the most designs will look beautiful regardless. I mean, to me, I'm very passionate about PCB design and I love printed circuit boards. And when you look at, Gerber data, or when you look at a design, in the virtual world, it's amazing. When you look at all the layers and you see all the layers, and it's truly a piece of art. And is beautiful, regardless of whether it's hand routed or auto routed.
You said electrons don't care what they look like. That just struck me as kind of funny, right? I mean, that's funny. Like you imagine, like they're hanging around and a song comes on that they really like and they can dance to it and they get up and they start shaking around like Elaine from Seinfeld. I mean, like they just don't care, right? That's great.
Exactly.
Um,
Exactly.
Seriously though, the argument is that the auto router gets you maybe 80%, maybe 90% there, right? But that you still have to finish the rest of the design, and it's kind of figuring out where everything is going and unwinding, at least mentally, that rat's nest that takes the time that the designers just don't want to do. They want to know exactly where each net is, and from start to finish, like the whole way through, right?
Mm-hmm.
So, what's your response to those folks?
The thing is attacking the design is strategic. You got to understand, you're attacking your critical designs first, your critical routes first when you're routing, but it starts at placement. Your placement is strategic, and it has to be it has to make sense. And when you're placing your design in, and designers, they cultivate this skill set as they progress in their career, is during the placement stage, mentally, they're actually routing the board. So by the time you finished your placement, you have mentally routed your board already in your head. You already know the plan of attack that you're doing. And of course, as you start routing, there may be some things that you may have thought were going to work, but actually once you started laying down some traces, you realized there's actually a better scenario. And what I love about utilizing the auto router is I can do several what if scenarios to see what different level of attack is going to be better in my approach. And if you're doing things manually, it's very time consuming. And like I said, when you think about, today's age where time is money, and how quick can you get to market? And so it's key to, figure out how can you design faster. Don't get me wrong. I'm very adamant or very a big advocate of workmanship and quality. But there's a fine balance between quality and speed, and how quick can you move forward. But this comes along with, sharpening your skill and cultivating your craft as a designer. And you do this by, just basically, grinding it out and getting several designs under your belt, as well as attending conferences and shows, and talking to other designers and get a feel. And I would tell you, one of the things I'm very adamant about is I don't care whether you're a junior designer or a senior level designer. I think you have to be open to be accepting critique and be willing to, showcase your designs to say, hey, this is my approach. How can I be better? And I think those of us who are willing to put ourselves out there to improve ourselves will truly elevate our skill set to move forwards.
When you talk about that placement strategy, one of the things that comes to mind is if you've listened to Charlene McCauley's talk on DDR5 routing, especially with the CAM2 memory that they use on all the Dell boards, and how long it took her and a Dell engineer to figure out how to properly route that and get the part as close as possible to where everything needed to be. It's a really fascinating talk, and as you know, she's going to be at PCB West later this year. Actually, it's coming up in less than a month now as we record this here in early September. I'm going to use that as a segue to talk about PCB West and your appearance there. So you are presenting a couple of classes, and you're also sitting on a panel. Let's talk about the classes first. You have one on complex PCB design, and you have one on DFM for Ultra HDI. Without giving away the store, can you share a few highlights of what you're going to cover?
Sure. So, first let's start with, the designs. It's a topic that, the last few years, it's really resonates with me and has resonated with the audience. And therefore I just keep evolving that presentation, because as designs are getting more and more complex, and you have a lot of designers who are retiring, or they're no longer in the industry. They've gone away. So you got a lot of young junior engineers or double E's who are picking or being forced to pick up this craft and learn how to design a circuit board. So in that course, I just give a general perspective of what it takes to design a complex board. But the question is even more simpler: is what's considered complex? I mean, is a 4-layer board or is it a 30-layer board? I mean, complex can come at you in several different ways. Is it heavy constrained? Is it high power? Do I got to worry about lightning strikes? Do I lightning protection? There's so many different things that make things complex. Is it budget? Is it resources? Is it time constraint? Because let's be real, time constraint is always the pressure that designers are under, because it never fails. Any project, they always want it yesterday. How fast can you get it done? Are you done yet? I mean, that's for the majority of my career. That's always been like the phrase, the catchphrase joke is, are you done yet? Are you done yet? Oh, by the way, we have more changes. Are you done yet? So in that course, that's what I cover, just the pitfalls of attacking and what would you normally see in addressing, complex designs. The second one is, I'll be covering is exploring the role of Ultra HDI, which, when you think about HDI and the evolution, you see different webinars today, such as like American Standards. They do a lot of good content on Ultra HDI and what they're doing. So it's not, you can't ignore it, because we are evolving into that arena. When you think about the chip world and how the chip world is now overflowing, and we're seeing this fine line traces and spaces in now or on the PCB itself now, it's we're going to have to adapt to this. But that leads me into like DFM. I think that's another one of the lectures I'll be giving is DFM and Ultra HDI. So when you think about you can design amazing things on your computer, but it's useless if it cannot be fabricated. So this is where collaboration with your fabricator is key. You have to understand as an engineer, what is the pocket, or where are your designer suites or your supplier sweet spots for manufacturing? And it's our job as engineers to mitigate the risk while collaborating with the supplier to deliver them product or manufacturing outputs. So that way it's a very smooth transition that makes them to have more success in building the project. So it's our job as engineers to set them up for success by providing them designs that are manufacturable. And this is where you hear the term like DFM or manufacturing driven design and MDD. And what we're doing now is we're left shifting. We've moved that insights and manufacturing up into engineering. And I always, say this in my lectures, is that you as an engineer have to understand the decisions you make at engineering and the downstream effect that those decisions have. And that's a skill set that, I was taught early on by my mentors of understanding when I'm doing my layouts and what effect are the decisions I'm making, whether it's placement or routing, how are they going to affect downstream in manufacturing? Whether it's fabrication or assembly, you have to understand those decisions. So those are the three categories that I'll cover, the three, topics that I'll be lecturing on. So I'm very excited. And, you mentioned Charlene, what she's doing, especially her and Terry regarding that specific routing there at Dell. And it's amazing content. And I'll be excited to see her, as well as Rick and Susie and several other, industry leaders who are presenting there. That show is amazing.
And Charlene will also be on the panel sharing a seat near you. That's the panel on the PCB designer / engineer of the future. And that takes place October 1st, which is also known as Free Wednesday. And that's the same day as the exhibition. It's one of 10 free sessions that day. Others on the panel, besides the aforementioned Charlene, is Steve Clark from Stanford. And we may have Amar Basu from Wayne State as well. Now, PCB West is, of course, the leading conference for PCB design and design engineering in the world. And the training aspect is a big reason for that. And you've played a big role yourself. In the summer of 2024, you began teaching the PCEA CPCD class at Wayne State University in Detroit. Now, for folks who aren't
Hmm.
familiar with Wayne State, maybe they should be because it's actually Michigan's third largest university with around 24,000 students. You then follow that up with a semester long course there starting in January, where you had, I think it was 23 students learning PCB design using the CPCD curriculum as the backbone of that class. Now, why don't you share with us what your takeaways were from that class? Was there anything in particular that stood out about teaching undergraduates versus industry professionals?
Yes, I tell you, one of the first things that really jumped out at me is even with master and PhD students in the class that were getting ready to fulfill whether it's their master's or PhD, is how many of them had no clue of what printed circuit design is. And when you think about academia in general, as a whole here in the U.S., I mean, PCB design is still, which I fathom as to why it's not a mainstream curriculum being taught everywhere. Um, Maybe that explains the shortage of why we have so many gaps, and the need or the request for designers has never been more strong. I mean, if you're a PCB designer, especially if you're a seasoned designer with 10 plus years experience, you're in high demand, and jobs are plenty. And it just surprises me. And that was one thing that jumped out at me. Not just at Wayne State. You think about Utah University. You think about Arizona State University. Um, there's a lot of universities that a lot of students that I come across that simply don't know, and they want to know. I mean, Wayne State. That's how I think. If I'm right, Wayne State, that course was demanded by students. The majority of the students wanted to know more about design and printed circuit design. So that's one thing that jumped out at me the most. If I was to say one thing, one particular thing, is the fact of the eyes wide open of students who didn't realize, what board design is, and how much it is, where you think about printed circuit boards and electrification in general, it's everywhere. And that, and they were design engineers that, or like I said, they were masters and PhD students that theoretically amazing schooling, some little projects in there, but truly had no clue of what board design was, or even they may have done a little project on some little tiny widget, but nothing. I mean, when they took the course, their jaw drops and eye open, like a deer in headlights. They're just shocked on how much detail and how much complexity and what it takes to design a circuit board. I mean, especially when you think about collaborating with the suppliers. Now that really opens the door of true collaboration or team collaboration, because in order to be successful, truly successful, you have to collaborate not just with your internal team, but as well as your external stakeholders, which is your fabricator and assembler. So that was the biggest thing, the biggest takeaway that really got me. But it's not just there at Wayne State; it's all over.
Yeah, you mentioned Arizona State University, which is right in your backyard. I know you're working with
Mhm.
them. Can you tell us a little bit about your role there?
So what I'm doing there at Arizona State is, it's not just me, but as Siemens, who's my employer, who I work for, we are doing a lot of micro badging or micro credential for short on demand training within our solutions to cultivate young engineers to understand the essence of designing, or the purity of designing circuit boards, but utilizing the Siemens solutions. And we're partnering with that university Siemens is, and it's amazing what's evolving and unfolding there. But that is not it's not just there at Arizona State. There's several other universities that Siemens is collaborating with and doing its part to help cultivate the next generation of engineers. So it's amazing, and I'll keep you posted, or I'll keep the audience posted. When I speak at the different trade shows of how things are unfolding in academia, where a lot of universities are starting to realize that they need to start teaching printed circuit design. But the issue is that most professors don't have the experience, the real world experience of what circuit board design is. And the professor, there at Wayne State was Professor Basu. Uh, I mean, he was the first one to pull me aside. Even after, having his PhD and being a professor there, I realized that I couldn't teach this class of what you're teaching, Steph, because I don't have that real world experience. I truly don't know. And I didn't think it was this complex. The little design, the flex design he did in one of his projects, he's like, I could see why I had so much difficulty and where I went wrong. And had I taken this course, it would have helped me profusely to be able to design something that he would have had more success with. And that's the thing. And is just, this is what PCA is offering when we think about our PCA training. And there at Wayne State, which is unique, is that not only are we teaching the PCA training as a course, an official course for credit for 3 credits, but the students have the opportunity to take that certification exam. And if they pass, when I say pass, if they qualify, with a specific score, a passing score, they actually get industry certified, which is unique to any other college courses out there. Is they get industry certified as a certified printed circuit designer from PCA, and so not only do they get a passing grade in the course, but they also get that certification. So it's a win-win not only for the university but for the student as well as for PCA. And like what we're doing at with Siemens here at ASU, the students are gaining that skill set and not just the craft of designing boards, but also they're getting some hands-on experience with the tools. So that way, when companies such as Collins Aerospace or any other major mil aero or even commercial industries, if they're looking for specific designers, there's a place they can go and look at a database and go retrieve or at least investigate some potential candidates that would be a good fit for their team. So
it's been a really interesting career arc you've had, learning design as a trade and through technical classes, right, at community college, and coming around to become an adjunct professor at some of the leading engineering schools in the country. It must keep you on your toes, spending that much time around the next generation of engineers. If you could go back 30 years in time, what would you tell yourself?
First of all, I'll just say this. I'm very blessed to have had and continue to evolve my career as it has. I owe it to a lot of mentors that have helped me. I didn't do this alone. And first, it starts with my wife backing my play and supporting me, but then all my other mentors helped me. If I could go back 30 years, a very simple, in a very rudimentary form or a simple response that I would tell myself is to be a proactive learner. Embrace the digital revolution, when you think about how things have evolved in the last 20, 30 years, and then understand the major global shifts, that have happened in the world, and always invest in yourself, both professionally and personally. That's at its core. And if I was to break that down and say, okay, well, what exactly do you mean? That's kind of general. So when you think about, embracing digitalization and the internet embrace it with full force. I mean, think about when I started, there was no internet, and now we have the internet. One of the big things is I've always, if I could go back in time and tell myself to learn a different language other than English, and especially learn a language as in code, learn to code. Understand networking. Invest in digital skills. Then there's, the focus on continuous learning and adaptability. That's one thing that I'd like to think that it's been constant throughout my career is continuous learning and adaptability. There's skill set obsolescence, and understand that that's real, that you can become obsolete in a short period of time, especially as the industry has evolved, if you choose to do nothing. There is a cost of doing nothing. And if you do nothing and stay the same, you will be left behind. And then there's, interdisciplinary knowledge, meaning that, don't just specialize in one thing, but be open and willingness to learn outside of your normal skill set, to be adaptable and pay attention to trends, especially mega trends. When you think about AI and automation, electrification and energy transitions, smart infrastructure and urbanization, sustainability. These are trends, that you should pay attention to. And when you think about, cultivating soft skills, and to me, soft skills you would think that that'd be a secondary, tertiary, thing to cultivate. But in my opinion, the soft skills are the most important because you think about communication. Communication is key. Collaborating with teamwork. I mean, I've been very blessed to, be an athlete for a long time in my career. And so working on teams working in a team, especially me being a Marine, I know what it's like to team what teamwork is, and cultivating teamwork is key. And I think as an engineer on an engineering team is key when you think about the multidiscipline and multi-domain collaboration and integration. Especially today's tools, you got the digital thread and the digital twin of how we're attacking designs today, and then problem solving. That leads into problem solving and critical thinking. These are those soft skills that I think they're important. Another area that is a focus, is just, I want to say personal, but it's like financial prudence. When you think about, you know, having long-term visions of smart investing and diversifying and understanding the global markets of how things, I remember always, being told like, oh, say you got to save money, and but when you're young, you don't really think about it. And I think now more than ever is, especially as we get older, you look back and say, wow, if I would have just invested here or put a little bit of money away there or did my finance a little different, I'd be in a different situation. So that would be another way I'd look at. And then lastly, which is I think is most important, especially now that I'm older, looking back, is prioritize, well-being and having a better work-life balance. I think today's automation with our tools and what we can do more with less in our tools, you have the ability to work, only 8 hours or not have to work as hard, but you can work smart and get more out of it, more effort out of it. And, we think about life in general, it's a marathon. It's not a sprint. And you have to be careful because, burnout is real and you can get burnt out really quick. And that's one thing you don't want to do. And I've been very blessed to have, burning passion for my skill set of being a printed circuit designer. Is, I've never experienced burnout, but I do know what it's like to get exhausted or just be mentally exhausted where you truly need a break. And it's not that you need a vacation, you need a mental break to just, come down off or at least, de-stress. And then of course, networking is vital. When you think about, well-being and networking is key. I will tell you that has been one of the strengths and one of the biggest things that has helped me throughout my career from the very beginning. As I transitioned as a technician coming out of the Marine Corps and evolving into a designer, and then from there cultivating that skill set, networking tied me into the right network, the right people, the right mentors that help guide me. And to this day, two of my biggest mentors is Rick Hartley, and Gary Ferrari. Those have been my mentors for many a decade. The last 2 decades, along with Susie and several other, Susie Webb and several others, Lee Ritchie. They've, these are personal friends that have helped me throughout my career, who've given me, very good guidance in evolution as a designer. So,
in other words, go hang around with a bunch of older people.
yeah, exactly. So that's funny you say that because when I think about my activities in my local Marine Corps League detachment that I belong to here in Arizona, when I go sit with these guys, especially these guys that some of these gentlemen were in the Korean War, those that are still alive that were in the Korean War, or they're significantly older than I am. They're in their 80s or sadly, they may be not sadly, but they're in their 90s. Talking to them, not just in life, but just when you think about our evolution as a society and as an American, being an American citizen, and how things have changed, and in some cases how things have not changed. And I think wisdom is in that older generation, but it's behoove us to pay it forward, meaning that now that I've got 35 years of experience in our industry, I owe it to those gentlemen or that older generation to pass it on to the younger generation, pass on the knowledge and the lessons learned, and hopefully enough of the younger generation will drink that glass of water that I put in front of them. But, some will drink it and some won't. And those that don't, that's their choice. But those that do, that will embrace and listen, sit and listen to the lessons learned, that knowledge will help.
Well, I will say this, and all joking aside, this will be 30 years that I've been attending PCB West, and Rick Hartley, Susie Webb, Gary Ferrari, some of those folks you mentioned. What was true then is just as true now. You will never find them anywhere but sitting down, talking with other designers, young and old, talking shop, just coaching, right? I mean, this is really one of the hidden benefits to going to that show is being able to meet these folks face to face, whether it's that show or PCB East, PCB Detroit, or, a litany of other places, right? Being able to sit down with these folks who are true experts and have their full undivided attention while you work through problems. It's really something. You can't put a price on it. And I'm thrilled to be a part of it, and I know you are too.
I couldn't have said that better. And I will tell you that I don't get where I'm at without attending those shows. And to me, the biggest golden nuggets that you will pick up from the shows isn't sitting in one of the technical sessions, even though those technicians are great. Those are golden nuggets. But the biggest golden nuggets you're going to find is in the hallways, at the coffee, at the coffee table, getting coffee, or on the show floor, talking with other people. And, after hours when you're sitting in the lounge and just networking. But not everyone is so, their personality may be that they're more of an introvert than an extrovert. And so networking is key. And there are so many golden nuggets. And like you said, at every conference and every show, you will see many seasoned veterans sitting there sharing and engaging, not just knowledge, but sharing personal life and making friends, and relationships are key. And at these conferences, especially PCB West and PCB East, you will find some amazing leaders that have, mastered their craft and continue to master it. And they're sharing that knowledge. And, to this younger generation or anybody who's willing to sit and listen. And I know even me, after 35 years, I will still listen and pick up golden nuggets because learning is a continuous thing throughout your life. If you're going to be in this field and in this technology, you have to constantly be learning and absorbing what is happening in the industry. And then, and especially in your skill set, how can you continue to sharpen that blade? And the more you can add into your bag of magic as an engineer, the better off you'll be.
Well, thanks, Steph, for all your words of advice and wisdom.
Awesome. It was my pleasure. Thank you for having me on.
Our guest today has been Stephen Chavez. We will see him and hopefully, the audience at PCB West in Santa Clara, California in just a few weeks. You can go to PCBWest.com for more information. For PCB Chat, this is Mike Butow. Have a nice day.